For those who use Monte Carlo simulation often, one of the big mysteries is how to generate a bunch of random numbers, say normal random numbers. In Excel, you do it in 2 steps. First, use rand formula to generate a random number within 0 and 1. Then pass it to the inverse normal formula. You end up with a normal random number. Through my work on the stock price modeling course, I was able to explore this method carefully and came up with a better understanding. The random number generation process can be thought of as spinning a wheel. The distribution of those numbers depends on how you carve the wheel. If you carve it evenly, you will have equal probability of drawing each number. But if we cut these slices in a non-uniform way, for example, with an increasing size, then the bigger the slices, the more chance of drawing those numbers painted on them. So in order to generate numbers normally distributed, you just carve the slices according to normal distribution. Hence, the generation process includes 2 steps. First is the random spinning. Second is to map the location to a corresponding normal random number. To model the random spinning, we need to quantify the locations of the wheel. On the spinning wheel, we first mark the locations, the bottom point being 0, top being 0.5. Then to the right side of the bottom point, mark it 1. This way, the locations will be numbers within 0 and 1. Then, modeling the random spinning is to create a random location number within 0 and 1. You can use modulo operation. It's an operation to get a remainder of a division process. You start with some number, then divide it over some weird number. The remainder of the division operation is very unpredictable, so they appear random. Then divide over the divisor. So that's within 0 and 1. Hence, we can use it as location number. To make sure you're producing normally distributed numbers, you just use normal distribution to shape the wheel. So let's think about what numbers need to be painted on them and where they should be located. They will be the numbers drawn when you do the spinning. That depends on the distribution. If we use standard normal, then it would be 0 at the center. Going to the right, numbers go up, all the way to infinity. Going to the left, numbers go down to minus infinity. The reason we model locations as numbers within 0 and 1 is because they can be treated as probability. So if I spin this wheel, what's the chance of getting a number smaller than 0? 0.5, right? So this location number will be treated as probability. We map the location number to a corresponding random number based on the density function. When we do the spinning, we will hit a location, say 0.84. What's the corresponding number? It's equivalent to ask, what x would give you the cumulative probability of 0.84? Well, you use normal distribution function to find out. To which point you will get an area of 0.84. That's what this normal inverse function is doing.